bass, horns, everybody! That don't kill me, can only make me stronger. I need you to hurry up now, 'cause I can't wait much longer.
Hello everyone. In this video we are going to be talking about another rule for finding the derivative. This rule is called the product rule. We want to start by looking at a situation. If I have a polynomial function, or a function, that's the product of two other functions that are being multiplied together. So here p of x equals f of x times g of x. We want to find out if the derivative of p of x is simply equal to the derivative of the first function times the derivative of the second function. The way I'm asking us to do that is to either provide an example or a counterexample to support what you think. Okay, so I want you to decide right now if you think this is true. If p of x equals f of x times g of x, does the derivative of p of x equal the derivative of f of x times the derivative of g of x? Decide if you think this is true. And as you're thinking about this, we're going to work with two functions. We're going to say that f of x equals x squared, g of x equals the square root of x, and p of x would equal x squared times the square root of x. So to see if this is true, we're going to do this two ways. The first way I'd like you to do, or to solve this, is to take that p of x function, which is x squared times the square root of x, and rearrange it like we did the other day. So change the square root of x to x to the power of 1/2, and then simplify this into one term, and this would be x to the power of 5/2, and then find the derivative of this function. You should be able to do that based on the work we've done so far. Once you've done that, take the function p of x, which is equal to x squared times the square root of x, or x squared times x to the power of 1/2, and find the derivative using this form that we are trying to find out if it's true. So take the derivative of the first function and multiply it by the derivative of the second function, and you want to compare your answers. So take some time to try that now, a minute or so. Now that you've had a chance to try that, you can compare your solutions with mine. When I find the derivative the way we did the other day, I get 5/2 times the square root of x cubed. And when I try it this way that we're trying to see if it works, I end up with the square root of x. And it's easy to see that the square root of x does not equal 5/x cubed divided by 2. So I think we can assume that the derivative of this polynomial is not going to be equal to the derivative of f of x times the derivative of g of x. And so if I give you a question like, find the derivative if the function is equal to something more complicated like 2x plus 3 to the power of 6 times 6x minus 7 to the power of 12, to simplify first, would be too complicated. It would take us too long. So we want something a little bit quicker. So that simpler rule that we're looking for is a rule called the product rule. The product rule states that if our function p of x is equal to f of x times g of x, then the derivative, p primed of x, is equal to the derivative of the first term times the second term plus the first term times the derivative of the second term. So if we have a product function, f of x times g of x, the derivative is the derivative of the first term times the second term plus the first term times the derivative of the second term. So going back to our first function, p of x equals x squared times the square root of x, which we said was the same as x squared times x to the power of 1/2. If we do it this way, I take the derivative of the first term, which is 2x, times the second term, x to the power of 1/2, plus the first term, x squared, times the derivative of the second term, which is x to the power of negative 1/2. And then I simplify. So here I end up with 2x to the power of 3/2 plus 1/2 times x to the power of 3/2. And now I have some common, now I have some like terms that I can add together. So 2 plus 1/2 is 5/2 times x to the power of 3/2, which simplifies to 5 times the square root of x cubed over 2, which is the same as the answer we got when we tried this, knowing what we know from before today. So we've kind of verified that the product rule works. Okay, so just a question to help us understand how and when the product rule can be used. Product rule is used on functions that are two terms being multiplied together, or two functions being multiplied together. So if I look at number 1, I have the function 2x plus 3 being multiplied by the function x minus 5. So to derive number 1, I would use the product rule, because I have two functions that have variables in it. If I compare this to question 2, I have 5 times x plus 3. Well, that first function, that first term, has no variable. So I would not use product rule. In the third question, I have the function 5x being multiplied by the function x plus 3. Again, that has two terms, two functions, two variables being multiplied together, so I would use the product rule. Question 4, I could rewrite as 2/7 times 3x squared plus 5x plus 1. Now I have a constant being multiplied by a polynomial, and all the terms in the polynomial are being added together, so I would not use the product rule to derive this. I would use the rules that we learned the other day. So let's look at an example using the product rule. Here I have the function h of x equals x squared minus 3x times x to the 5th plus 2. If I want to differentiate this, I could expand everything first, but that's a little bit more complicated than we're looking for. So rather than expand everything first, let's use the product rule, which states take the derivative of the first term, multiply it by the second term, add to that the first term, times the derivative of the second term. So in this case, the derivative of the first term would be 2x minus 3. The second term is x to the 5th plus 2. And to that I'm going to add x squared minus 3x times the derivative of the second term, which is 5x to the power of 4. Now that I've done that derivative step, going to simplify if I can. And I can simplify here by expanding everything. So I end up with 2x to the 6th plus 4x minus 3x to the 5th minus 6 plus 5x to the 6th minus 15x to the 5th. And gathering up all my like terms, my final answer is 7x to the power of 6 minus 18x to the 5th plus 4x minus 6. And then my last example in this video, one more function. I have the square root of x times 3x minus 2 times the root of x. So again, we'll use the product rule. And simplifying this first, I get x to the 1/2 times 3x minus 2x to the 1/2. So finding the derivative, y primed, I find the derivative of the first term, 1/2 x to the negative 1/2, times the second term. And to that I'm going to add the first term, multiplied by the derivative of the second term, which is 3 minus x to the negative 1/2. And now, just like in the first question, I need to simplify. So I'll distribute into the brackets. And by distributing, I get 3/2 x to the 1/2 minus 1 plus 3 x to the 1/2 minus 1. And then gathering up all my like terms, I end up with 9/2 x to the 1/2 minus 2, or in proper form, 9/2 times the square root of x minus 2. Okay, and that's all I'm going to do in this video. Just a few examples of using the product rule in class on Monday. We'll look at some additional examples and give you some time to practice. Hope you enjoy your weekend.